I want to be on the start screen. Be like, yay. Not enough start screen. Never enough start screen. Loud? Loud. Too loud. Too loud. 7 me. Yeah, yeah. Yeah, yeah, yeah. Yeah, yeah, yeah. So I'm gonna be rough sitting right about here. That will be my position. It will be the infamous position, I think. A generous amount of water left over. Still pretty tasty. Alright, that one goes up there. Yeah, that one goes up there. I want to be up here. like so. So that whenever I do whichever one of these effects I do, the screen on the screen, then it will be the screen on the screen that I screened. Will I ever get it right? We are unsure. Wait, why are there two of these? I don't know why there's two of those. It's a mystery. Wait, does this work? I don't know if this works. Peculiar. Alright, what is... Maybe I should try one of these for once. What does this one do? Well, that's an effect. That is definitely an effect. I don't know what to think of that one. I finally made a to-do list for the engine project. I was kind of disappointed at the loss of my my Wheel of Fate. So I found all of the things, and then I may have added a few hundred more. Yeah. Broke them down to different categories. There's a few. Maybe just a few. Some of these are easier than others, and some of them are more complicated than others. Which one to do though? I think I was working on. I was sort of working on ray tracing before I decided I would just stop for the day. And it's certainly a good option, I guess. There's a pretty sizable list here. I think the best part is this isn't even, not even everything that I could potentially come up with. I could make up so many more items to add to the list. So many. Compute shaders. What if I did compute shaders? No, not feeling it. Don't think it's gonna be compute shaders. Just script your batching. That's it's a maybe. That might be a maybe. A scene graph for Vulkan. That might be a maybe. Maybe I just go back to Vulkan. Then we go back to doing ray tracing, probably. If I remembered what the function was called. Extension. File extension. Too many file extensions. Okay, this is substring. Would this be like a string view? Yeah, it probably could. turn that off because I'm not committing right now. This can be string view. Like there's string literals, but there's not string view literals. Oh, what am I even doing? Don't even know what I'm doing sometimes. This is extension types. I'm just randomly optimizing this one function. Because of course. The head pats. I like maybe if I had like one of those head pat gifts. And then maybe. It would look ridiculous, but it would work, I think. I think. Pretty sure. Pretty sure, maybe, kind of, sort of. Alright, so that should now be a span. I don't think I use this in any other weird places. So, I could do... ranges... find... and then we want to find the file extension in shader x types extension then if found is not equal to shader extensions end, found stage can be the value that I pull out of the thing. I don't necessarily think that it's all that much more convenient. Because it really isn't. But it might be. It might be more descriptive. Possibly. Maybe. Perhaps. I sort of wish there was like a then function. Be like, find this. And if you find this, call this lambda. Or something of that nature. Why am I poking shaders for? I don't even remember. Just saw that and I was like, we must shader. We must shader. Destroy. Destroy. Why are we destroying? Why aren't we destroying? I think I was gonna do this last time. Figure out which way the matrix goes. Figure out how to get the addresses of all these things. Do they have to be on the CPU or the GPU? I'm not really sure. Doesn't seem like there's a whole lot of good, well put together things. The hair. The hair is very hair. It almost certainly is. Maybe. Possibly. Perhaps. Wait, isn't this supposed to be the bottom level? I wanted to make some bottom levels. No flags. This would be a build. There would be some source. There'd be some kind of pointer. There'd be geometry count, which I don't even know. I don't know right now. I just can't even sometimes. Good to know. The name of low polycat? The low polycat. It's the ray tracing. The ray tracing. I'm basically just starting out with ray tracing. Like I read the documentation, the manual. No, the specification. I read the specification, that's what it was. About how the different ray tracing structures work. So now I'm thinking I need to figure out how to like fill in these structures and actually build one of these things. Which is kind of like the entry point into all of this ray tracing stuff. So maybe I would consider it something like what would I call it? I'm trying to figure out how to, like, hello world triangle my way into ray tracing. And to do that will require an acceleration structure of some flavor. Multiple, even. Get acceleration structure device address, for example. That is a function. That's definitely a function. So if I want to create an acceleration structure, I have to figure out whether or not it's like the top structure or the bottom level structures. And then they have to like nest into one another. But in order to build them correctly, I have to figure out how big to make them. And figure out how big to make them, I have to fill out the build geometry info. And then we call get acceleration structure build sizes, I think. Expects 5 arguments. A device type. That would be this. A build type. Yeah, they're computed at runtime. You can build them either on the CPU or the GPU, but they're built at runtime, basically. I was like, well, what if I just do the GPU one? Which one is it? I don't even remember what type this is. Acceleration structure build type. Let's say device. Because why not? Geometry info. Build sizes info. Alright, so geometry info would be this data structure. And we have an int pointer and build sizes info. Build sizes info. I don't know what these are, but I think it's an array. Acceleration structure types. Oh wait, these are the outputs. Yeah. Okay. Wait, this is structure type. Acceleration structure build sizes info. And I don't think I want to have any kind of null or next. There's no next pointer, I don't think. And the rest of the values are going to be 0, I think. And I don't know what the int pointers are, so I'm going to have to look that one up. Get. Put the prefix on here. Acceleration structure. Build sizes. Oh, there's a link to it. Maximum primitive counts. Pointer to an array of geometry count values defining the number of primitives built into each geometry. So there would be one of these. So it would be an array of 1 for this structure. And it would say how many geometry would be built, I think. So if I did like 1 instance, perhaps. And then it would be build sizes, I think. I think, maybe. Build sizes, this must be null. These get filled in. Geometry count, uint 32 values. This must have think it's... I don't know what it is. It's like the geometries. I don't know if it's the geometry instances or what it is. But, yeah. I think it's like that. I think, maybe, perhaps. Hello there. Welcome to whatever I'm doing today. I just feel so meh. So in the descriptions for building geometry, there's an array of geometry structures. Then the geometry structure I think it's something like this one? Yeah, this one. Acceleration structure geometry. If you ever desire a song, exclamation song will usually tell you what the title is. But yeah, most of these are from .hack right now. I think when it comes to a geometry, we have instances. And I forget if there's like a count of instances in the individual geometry or if it's just a thing. Because it's like an array of these, and then each one has like a list of, or a union about what it could be. And then these points off into Narnia here. And I'm thinking this is an array of entries. So this structure would exist. Points at an array. And I guess the number of items in this array would be forwarded to the range here, the top level thing. I think. I I think. Geometry count. I don't remember what that was for, but I don't think I want that. Like, I want to tie that to some actual value. Like, this one could be probably the span size of the top level instances. I think that's how it works. I don't know that I will actually be sure until I generate a bottom level one as well. And I think this only produces like one information. Although I could be wrong about that, unless if there's a count of these, then I don't know. Yeah, this is just a pointer to a structure. This is a pointer to an array. This is a pointer to the structure. This will only give me one of the build parameters. Device or host address members are ignored. Of build info. Yeah. So this would be the build info. Would that include geometries though? Because geometries probably point at something. Build geometry info. Geometry pointer. Geometry data instances. Alright, so that one's a device or host address. But this one isn't, I don't think. So I think I need the geometry structures. Yeah, so that would be the count of those. I should probably figure out how to actually like call into these these things and start to maybe get some sort of inference as to how they work. Some idea. I don't know if the validator will cover all of these cases or not, but I feel like I'm getting somewhere, maybe. This is structure, geometry. I guess we would use pointer geometries. That one's fine. RT gems? No, I've never actually read a whole lot of anything other than like the spec. However, I've written my own ray tracers before, so I sort of get it. It makes sense. But figuring out the API for it is a bit tricky, I guess. Because we have these acceleration structures, which are probably BVHs under the hood, plus some metadata. Along with a bunch of transforms and stuff. And the graphics card is supposed to generate these, and then once I have them, the ray trace functions use the ray tracing hardware to like traverse the structure. And these structures are hierarchical in a way. So like there is there's like a set of like triangles or AABs. AABBs are probably a bit easier. There's a great many steps. I actually broke this down into like 4 different to-do list items. Because I figure there are going to be like the acceleration structures for the different flavors. That's probably going to take me a while. I probably need to stick the instances one in here. Although it's not really that much different. So you have instances which are just like the other two, but with like a transform attached. So like they reference each other. And then once I have an acceleration structure built, we can give that to a shader. And a standard shader can execute ray tracing commands to like walk the structure. Or if I get this one working, then I can dig into ray tracing dispatch, which will take a while because there's a ton of setup for that. on top of the acceleration structures. Why am I even doing ray tracing? I don't even know why I'm doing this. Somebody pointed it out across multiple streams, and I've been like, I guess I'll do it. I guess I'll throw it in, because why not? I'm here. I'm doing the thing. So we can do the thing. So get acceleration structure build sizes. Returns void. That's nice. But its results are stored, supposedly, in this function. So if I filled this out correctly, which I don't think I did, then after this call, I should have the size of the acceleration structure, supposedly. So we could just add dead code. Yeah, just throw one of those in there. Exit early. That way I don't have to get all this stuff right, and I don't have to get the stuff before here exactly right. I just have to get it sort of mostly, almost kind of right. Command buffer. Maybe I get rid of the command buffer. Yeah, that can wait. And then I have to figure out... Wait, why are there... Build range pointers? Yeah. Primitive count, primitive offset, vertex, transform. It's like... I already forgot what it was. Primitive count. Let's just copy these. That's not the comma. I want the comma. We'll go up and insert. Like so. So we got some of those. I will need for later. Build structures. I feel like I could call this maybe during an int or something. Maybe start. Yeah, we could do device. Build structures. And then do bottom level geometry. That would require maybe a span size of the bottom element. I guess it can be an array. That's probably fine. And then we have the geometry types for the other kinds of structures. I almost don't want to fill that one out yet. I kind of want to debug this and see what I get out of acceleration build sizes. This file is just a casual 3,500 lines. I think I'd break it up by now, but no. Also, you'd think I'd get like a debugging attachment thing for Vim by now. As much as I use it, I have to try those. And I could debug in Vim, then I wouldn't need the debugger Visual Studio anymore. I don't know if it has. I don't know how the debug extensions are because I haven't tried them. They're supposedly the same on all platforms, though. More or less. Alright, so we got build sizes. It gave me some memory here. So I need 600 bytes and like 800 bytes for the scratch. That should be good, I guess. Maybe. I don't know. Oddly specific, but I'm not going to question it. They gave me a size. What more could I ask from it? And what if I ask for a host build? Build sizes. Get up 0. Apparently it's the same size. Meh. Or you do the either or, but I don't really need the either or. Alright, so to make a bottom level geometry, I want one that is triangle. So we'll do dot triangles. I don't know what's in one of the triangle structures, but I'm about to find out. I guess we could also make it opaque, because why not? Opaque is easy. Opaque is plenty easy. Well, I should put the page number in here. Because I'm not done with that one yet. The flag's after the little bit of, the little thing. The marker. Yeah, okay. So, these will supposedly get filled in with different data structures. Different things. Triangles was 3190. Which is down here. Triangle data. Structure type. Structure type. Which one? Acceleration. Structure. Geometry. Triangles data. Hello there. Likewise, this one's probably going to be something like geometry AABBs, I think. How am I doing? Not great. Today is not good. Format of each vertex element. A vertex format. Let's do. How about R32, G32, blue 32 signed float. Host or device address, vertex data. Mm-hmm. Let's see. It's vertex stride. Bytes between each vertex. That could match the other data. That's a long comment. Yep. Mm-hmm. That device address cannot be initialized with a null pointer. Can it though? Can it though? Device address. Host address. Hello there. Oh. Ay, 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 ay. But yeah. Okay, so maximum vertex. The highest index of a vertex that will be addressed by a build command using this structure. presumably so it knows how far it's allowed to go. Perhaps, maybe. Index type. Because why not? Index data. Transform data. Wait, optional? Why is it optional? Performance cost, setting the max vertex. I don't know if you can do that. Because for starters, the unit max for a given type is usually used as like a marker. So it would have to be at the very most, like maximum -1. But also that's probably used for like checking. Like it might be an actual count of some kind. It might not. I don't know. Unlike the stride for vertex buffers in vertex input binding description, must not exceed max vertex binding input stride. Vertex stride for acceleration structure geometry is restricted to being a 32-bit value. Like 2 to the 32nd -1, apparently. According to the specification. It's very flexible, I guess. Why you'd want to make it that ridiculously long, I don't know. The format features a vertex format. Must contain acceleration structure vertex buffer depth. Let me Maybe I should put that in my thing here. Yeah, that's a thing I don't really check. It's the format features. I need to look up all the format features because there's a lot of places where I just use formats without really going into depth what they can do. Hmm. Yeah. Yeah. I guess it would be size -1. It could be, I think. Unless there's some sort of restriction type here. Index must be uint 16 or uint 32 or none. None? None. None KHR. Yeah, okay. Okay. So if I do all of that, we fill in one of these. BK transform matrix. Wait, did I make note of that one? Triangles data, index data. There's another device address, which is the optional. I could spell. Transformation from the space in which the vertices in this geometry are described to the space in which the structure is described. So I guess if the structure is in a different scale, I guess. So that's triangles. That's triangles. Next data, vertex data though. That's something that needs to possibly maybe sort of exist. Alright, and then on page 3196. Triangles, opacity micromap extension. Data. Wait, triangles data can have one of these. Okay. Gives. I want to copy here. I want to make note of these in case I feel extra adventurous. Fine, I'll do it this way. We'll do it that way. Why are there two of those? Why you be like this? Raytracing motion blur. I don't know that I'd want to implement raytracing motion blur. I don't even like motion blur. I'll make note of it though. Geometry, AABB data. AABB positions KHR structures. Let's see, next is null. We don't support anything here. Data, stride. I mean, that does seem a lot more complicated. What does one of these look like? It's a bunch of floats. See, it's the 3D minimum, 3D maximum. That's not terribly bad. And I think that's how I do my bounding boxes. Ay, 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 ay. Ay, 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 ay. Acceleration structure vertex bow. I mean, I think floats would be valid. That's what they use here. So that one's probably, safe-ish, I guess. Alright, so in the bottom level, if we say... see, primitive counts. The primitive counts. I guess this would be the number of... Would it be like triangles? Or would it be... I don't know. Or would it be primitives? 3 of those, 4 of those. Sure, why not? I don't know. I'm sure it has some meaning. Build size is 0. This one would be build size is 1. Let's see, info 1 will be like the bottom level. Because why not? Alright, what do I get out of all of these? The first 2 should be the same. And this third one is something else. It's definitely something else. Then we have the scratch register buffer. Scratch buffer. I think the scratch buffer gets discarded every time. So I could use a single scratch buffer, I guess. Just like figure out the maximum amount of memory I would need. Possibly. Maybe. I'm gonna be right back. Somebody left my door open again. I do not approve.
I've returned. Yes. I've definitely returned. I may have had a sweet snack. Apparently, I've also returned just in time for the hydrate. Mm-hmm. Okay, so now that I have some idea how to build or no, not build, how to get the sizes that I need to build an acceleration structure. I think we can just take whichever value and supposedly use that to figure out how big of an acceleration structure to create. So I will need a line size. I'm probably also a marker for the top level or not. So we'll put those in there. Let's see, I'm going to need an alignment or an address. I'm going to need an address. So I want to acquire size memory. at 256 byte alignment. At a given offset. So that will give me that, and then we want the size. And I could potentially just like round up the size. That would probably be fine. We'll set the two different levels. I don't know if I need any flags. I kind of think I don't. But then again, I don't know. And then once I have the offset and the size, I think we want maybe I will save these. It does seem a little bit extra, but I guess I could do it. So then I could change this to buffer offset or struct offset. A struct offset. And then we can just delete that. And then it will be. It will be. It will definitely be. So then, after we create a bunch of these things, I'm going to need to figure out the scratch buffer requirements. Which could potentially just be shelved at the end of the buffer. Yeah, maybe. And just take whatever's at the end of the buffer and be like, here, use this. That could maybe work. Otherwise, I'd have to like copy the structures around or something weird like that. Which I might have to do. I love this song. It was like the best one. I wanted to like set a video to this once, like on YouTube, but yeah, YouTube is not happy with that. So I had to take the song out of it. Yeah, this song. In the land of the twilight, under the moon. I had this song in the background of the video. I had actually kind of like synced up some of like the stuff in the video to the music. Sort of. It wasn't that great of a video to begin with. But I don't think I think not having the music just kind of made it all that much more meh. It's just kind of boring without the music. It's on my channel though. I don't think anybody watches it. It's one of the Final Fantasy 14 videos. Yeah, I have a YouTube channel and there's like hardly anything up there because I don't like watching or not watching. I don't like editing video. Because there's nothing good there, I don't think. So I hid it behind a command instead of being like, here's this channel of unrelevant content. You subbed. Oh my god. Oh my god. Though I will say that something I was thinking of doing was that I downloaded some of my streams recently. And I was thinking of like maybe cutting them down a little bit, uploading them. It's sort of a meh. How many gigabytes is this? 90 gigabytes. Probably should upload them sooner rather than later so I can delete them from my system. Oh my god. I forgot that did that. YouTube sends notifications to the overlay. Because I was gonna be like, oh, I'll dual stream, why not? And it never updated them on the YouTube side. So it's just like, oh well. It's how infrequently that, it's how infrequently people subscribe to the YouTube channel. The secrets and the lore and the Easter eggs. You know. I love to hide Easter eggs in things. All over the place. And just like everywhere. The code? Not the code. How long have I been streaming? Like in general or what? Because I've been on Twitch for I don't even know how many years. Let's see, I need to how would I even find that out? I know. The age command. I've been on Twitch since 2013. And I basically signed up to Twitch to like stream programming originally. So that's like 11 years. Shirane is the name of my character in 14. But it actually predates 14 as well. See, I actually came up with all of my channel info names, channel names, back when I was doing IRC. I was like, oh, I need some alternate nicknames. So I used like Mesaka as the primary name on IRC, and then I would use either Yukara or Shirane as alternates. Well, I did eventually listen to those. Probably closed them afterwards, but I listened to them. They were pretty good. Copying acceleration structures. Is that what I want? Acceleration structure object can be compacted in order to performance improve. Application must query the size before for doing the thing. Serialized acceleration. Wait, you can serialize an acceleration structure? Can I really? Can I like just compact them? Which function call? Which one? Where? This is a data type, a structure. And this is a structure field. So like this structure is called physical device acceleration structure features. And then this on-off variable is called acceleration structure. This on-off variable is called descriptor binding acceleration structure update after bind. I like how it's a bool, but it's 32 bits for just an on or off value. Like, who does that? Why is it 32 bits for an on-off? The future is now. It's 1 bit for the Boolean. 31 bits to make sure the bit doesn't feel lonely. Plausible. I have 7 friend bits when 31 friend bits will do. Yes, I'll call them friend bits. It's time to crack open the mochi. It's so mochi. Mmm. Why do they call it acceleration structure? I don't know. I got no idea. Copy acceleration structure to memory. Copy the source structure into destination structure. Niche penguin. The niche penguin. The deleted user. Oh yeah, the deleted user. I don't know why he went deleted. But he did. Dropped in the stream. Acted all like memes. Chatted with me a little bit. Disappeared afterwards. I saw him like pick like 4 or 5 different names before disappearing, so like it's what it is. Also, hello there. Copy acceleration structure mode. You can do clone. You can do a raiding party of 54. Hello there. Welcome everyone to the thing, the program. Working on ray tracing today. How'd your stream go? Jessica Mack. I don't think I've heard of that name before. Or if I have, I haven't seen you much. Because it happens probably at a different hour. But yeah, I'm reading about acceleration structures and all of the copying modes and stuff like that. It's definitely a thing. It's not as easy as just going RTX on. It's so much more complexity behind it than that.
acceleration structures be crazy. Like it will. I think we'll do the shout out thing. Cause why not? I was like checking in on the stream, see what it was about. Make sure I spelled it correctly, because would you believe that I've spelled streams wrong before? Don't want to do that, so I have to make sure I copy and paste and go to the right place. I'm a bit chaotic sometimes. Just a bit chaotic. I see code though. There's code in the Von. Lots of code in the Von. Graphic stuff, probably. So yeah, I work on graphic stuff. I work on operating systems. I do assorted programming of all sorts, which is what assorted probably means. And today's project, I guess this is the project of the month, because I've been at it for a few weeks since I last changed which project I was focusing on. This one is a game engine. It's written in C++. I use a mixture of a variety of C++ versions, but I'm up to 20. C++ 20. This project is very, very old. I started this project before I started streaming on Twitch, and because the Twitch account age I found out was like 11 years, this project is older than that. So I think it's like 12, 13, maybe more years at least. Very, 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 very old. Lots of rewrites happened to it. I think it is currently in a runnable state. I have a 3D model that was loaded in that we can draw. This is the newer Vulkan renderer. And then I think the older OpenGL renderer is just like totally borked right now. So I'm kind of in not the best place with the engine in terms of like features, but that's what happens when you end up rewriting stuff. Like my older renderer had like the boxy voxels. Actually had like a scene graph. The art is floating and spinning. There is network, like client server stuff, but it's all kind of very, very minimal. It doesn't work too well. There is a lot of like custom backend stuff in this whole thing though. Like I parse my own floating point numbers. I parse my own JSON. I
write a ton of stuff from scratch that probably shouldn't be written from scratch. Kind of for the fun of it. I mean, I parse my own floats. Have you not seen the stream where I was like, I'm gonna parse my own floats? This thing with the giant table of like exponents and like it parses the exponent numbers. And like it does the binary conversion to put it in IEEE format, and then we like bit shift all of the exponents together, and then we reinterpret that into a double, and then it just works. That stuff. I didn't write this originally for like JSON, but I moved it to parser class. It's a generic thing. So yeah, I wrote a floating point parser. It really works. And that's what I mean by like parse my own floating points. I also like have a decompression library. It like does all of the bitstream stuff, so it can like unpack. I mostly just wrote it for like the PNG loader, but it is technically generic. Technically, that's a lot of numbers. That's a lot of numbers. String parsing. Float to string. Yeah, it is kind of involved. I think that one took me like 2 days to get right. I actually think I have that. It might be in my server, I want to say. I don't remember where I put it, but like I wrote one that went the other way. And it was for a different floating point format. Oh, this is my test of the posits number system, which is an alternative to like IEEE. So that one was fun. Yeah, somewhere in here, I don't remember where, there was float to string conversion. And it's kind of a disaster, but it does mostly work. And then, of course, there's the easy stuff like PNG. Easy, I say. Is PNG really easy? Was it PNG or was it image? I think it was image. It's like load PNG. Load Pong. No, load PNG. So this is just a PNG parser. Load Pong. Don't load Pong. I think the other format I support is the bitmap. And I think I also have like my own format at one point, which is just a different flavor of bitmap. I don't think I rewrote that one. I don't think that other one works anymore. It was like all in with PNG. Hash. I wrote a hash thing, which is just like CRC32 and Adler32. It's a miracle we have a 3D model spinning around. It's Obsession. Best song. I love Obsession. It is a good song. What if I model the CRC intrinsics? I don't think they existed back when I wrote it. I told you this engine was old. That said, I have my own math library, and my math library is full of intrinsics. How come I must know? I'm kind of obsessed with this program. So the model that actually gets loads in a format called ECV, which is a custom format that I wrote, and a custom format that I wrote an exporter for. Somewhere in one of my directories, there's like a Python file inside of a blend file that's like the ECV exporter. And then I also support the wavefront files, and now I have GLTF as well, thanks to a great amount of effort. I still don't know if GLTF works properly, but it's close. Very close. Am I completely self-taught? Or do I have a degree? I have a degree in, like, network administration. Like, configuring routers and servers. And when it comes to programming, I am almost entirely self-taught in programming. Like, to put it into perspective, when I first took a programming class for, like, my degree, I was like, I literally know all of this stuff already. But I will do the class anyway for credits. I went a little bit above and beyond in that class. Just a bit. Like, I made ASCII art or something. When did I leave the real world? Or come to the real world? Did I ever come to the real world? I don't know if I ever came to the real world. the ASCII art? I don't think I do. It was a school project. I think it was like a vending machine or something. So I made like ASCII art for the vending machine. Like the UI on the console. And then I also did ASCII art for, I think it was like a bowling score simulator thing. Yeah. I'm surprised I even remember what I did in a class that I took, like, I don't know how many years ago. Just the arbitrary stuff that I remember. Like, I think we had a substitute teacher for, like, the Cisco classes. And I still remember his name. Will not dox, but I do remember it. My Cisco instructor was kind of surprised that I had never done Cisco before with like how easily I flew through that class. So yeah, I know a lot about internet protocols, a lot about machine programming, because I used to like write 6502 assembly. I tried my hand at 86 assembly once upon a time. Like to actually write a serious program in it. I don't think I've ever written a serious program in x86. I've only ever written like small things, like shell code or something, or little loadable modules. The CAN bus. You know, they use the CAN bus in like industrial control systems as well, right? Like with robots. It's very, very versatile for like high noise uh, electrical environments that need signaling that's fairly reliable. It is probably most predominant in like the automotive industry though. I think it's also present on like locomotives, like trains. Very, very versatile. I was thinking of like if I ever did my own home automation type thing, I'd probably base it around CAN bus. Either that or the two-wire thing. Whatever that was called. I2C. I squared C. Whatever you want to call it. Because, yeah, not only am I self-taught in, like, programming, I'm also self-taught in, like, digital electronics and electrical engineering. Sort of. And I don't think these acceleration structures are writing themselves. Absolutely not. I've been on quite a rant now, haven't I? Clearly. And I still don't think I've ever found out what the what the stream was about earlier. That's how long I've been on rambling. You're gonna take off. I will see you some other time, hopefully. Wave. That reminds me, I need a wave emote in my list of notes. Why are you my clarity? Why aren't you my clarity? Yeah, yeah, yeah. So we'll go back to the top of this function. And I gotta put all the ray tracing stuff somewhere. Probably in pointers. Pointers of acceleration structures. So I need one for top level. And then I need test. Test is the best name. I wonder if acceleration structures, I thought they needed it to be like all the same type. So they make one for triangles and one for bounding boxes. Just in case. Because in order to build one of these, you have to specify a geometry type. Yeah, the geometry type must be the same. So like if I have multiple primitives, they have to be all the same. All the same, all at once. So it would be the bottom. I guess one for triangles. And then there's going to be one for bounding boxes. Which means I'm going to need a different structure if I want to test both of these. So we'll just take this and then we'll put another one here. Because why not? And that one can be the bounding boxes. To satisfy all of the esoteric requirements here. Which means I need one of these for the triangles. I don't actually have 4 entries, but I might. I might just have 1 entry. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . I don't know. We're going to do info 1. And this one can be info 1. That one can actually be triangles. This one can be bounding boxes. And then this is just kind of here to test what a host would be like, I guess. To do delete this. We don't need the extra E much. So we'll put that up there. And when it comes to triangles, we'll put triangles. I guess they can go here, but I don't really have an entry point for them. Should have put a marker down here. The acceleration structures. What's the point of copying acceleration structures? I think the main point behind copying acceleration structures is actually kind of twofold. I think one would be if you have to move them out of the way, probably to compact memory. You could either delete old ones and then copy existing ones in their place. I think there's also a way where you can compact a structure that already exists. I think that there is an option that lets you like I think copy them in a serialized format so they can be taken out of GPU memory, cached probably, and then re-uploaded. At least that's what I assume that one action. It wasn't entirely clear. The kitty. The kitty. Must pet the kitty. So yeah, there's clone. There is compact. There is serialize. And then there's deserialize. And I'm assuming that deserialize serializes to a semi-opaque format, which I presume means that you can like cache them or copy them between devices, maybe. I don't know that they would persist throughout many devices, but I imagine that there's some level of reusability there. Copy acceleration structure to memory info. What does that look like? Structure, address, mode. Memory pointed to must be as large as the serialization size. Mode must be serialized. So I guess you have to serialize if you copy to memory. But yeah, I think it's mainly you can copy them just so you can move them around. Otherwise, they would be stuck in place. And you just have to like rebuild them if you, which is probably more expensive than moving it. Although I don't know actually what the performance characteristics of copying one around versus like doing a serialize and deserialize or a build. I can't imagine a build would be very inexpensive though. Building the structure sounds kind of involved. I feel like I'm getting closer-ish to something that kind of sort of maybe almost makes sense. And it's mostly just get the build sizes of everything. But there is some value in that, I guess. Wait, why is AABB take up so much scratch memory, but very little acceleration structure memory? And then triangles take up a ton of acceleration structure memory and very little scratch memory. Oh, the mystery. The absolute mystery. I almost kind of wonder what kind of data is in these things. I'd be tempted to like graph it or something. Do like a pixel graph of all of the data. Which could be done by like copying the alias to memory into like a texture and then telling a shader to like draw it. That sounds like a ridiculous idea. Why would I do such a thing? Okay, so the driver code. I don't think any of the driver code is open source. That sounds like it would be deep in the dark depths of the ICDs or something. Besides, if it's going to be in any driver, it would either be in... I don't even know. I don't even know which driver I would look in. And I'm not exactly about to go digging for it, because that would kind of influence my thoughts about how to implement ray tracing if I ever wrote my own driver. Imagine that being a concern. Imagine being concerned. Like, wait a second, why am I trying to edit in here? Nope, don't edit in there. Nope, nope, nope. I want to edit in here. Before I start typing, like, them commands into the thing. And being like, how do the letters get here? I've done that before. Absolute ridiculous silliness. Because, yeah, believe it or not, but I want to make my own graphics driver. At some point. For a graphics card of my own design. At some point. But to do all of that would be incredibly difficult. Chips. I think I would probably end up using an FPGA. What does this want? A device. A device reference. Device? So we'll do this. Although if I could make my own chips, if I could like fab chips, I would totally attempt to do it. But fabbing chips is ridiculous. I don't think I could fit a PCIe seared as a GPU core, a couple of shader processors. I don't think that would fit in a tiny tape out. It sounds like a very large tape out. Blocks. All the blocks. I mean, I don't know. If anything, if I were gonna fab anything commercially, which I really don't think I could afford, I would go through probably one of the shuttle programs and just do the entire dye area myself. But that is so far out of what I'm capable of like doing. That I don't think I would ever fab anything unless I like do it myself. And if I do it myself, it's not gonna be a processor. It's gonna be like I don't know. I'd be lucky if I got like a shift register out of my own fabrication. So it would be much better if I just used an FPGA or and didn't worry about the chip complexities. So I want to create the top level structure here. And then we give it the size from build sizes 0, acceleration structure size. So we'll do test triangle, and then we'll do test a BB something or other. So we'll make all of those. And then I'll do some ifs. Now let's do this as probably a 4. Yeah, we like for loops. For loops are good. We do size, and we will find build size. If that's greater than the build scratch size. This is basically just like the max function. I could probably just write the max function. Let's see, it would be A, B. What did they do before FPGAs? They got logic blocks, like the 7400 series, for example. And then they would just like glue a bunch of those together. Or they would run simulations Because circuit simulations are actually pretty good, and you still have to do that for integrated circuits, like ASICs. That's a good put. This is in a lambda. A else B. There, max function. Or what if I do set maximum, and then we have like A is a reference. This returns void. A equals A greater than B, A else B. You know what? B greater than A. And do B else A. Sure. Sure, why not? I just use the standard. There's probably a standard maximum. I don't know where that comes from, but maybe I should just use that instead. Yeah, Because why am I doing this? Why am I like making a maximum function? Is that from algorithm? Why are these down here? Maybe we sort them. Was there a point to sorting them? No, but I want to do it anyway. I don't need to do that. It's a little bit redundant. So we'll also put update scratch size in here. In case I like copy the code at some point, which I probably won't. Let's see, what else do I need? I need a command buffer still. I need device addresses of things. So much setup to get this right. All the Raytrace stuff is like based around the idea that you're going to give device pointers, which makes it that much more inconvenient. Like the build ranges. Build ranges. Yeah, that's kind of a thing. Because like this thing for the triangles here, you have to fill in a bunch of vertex data. You have to fill in index data. It has to be like space for the vertex stride. I kind of just assume this format has what I need in it. You know, maybe I'll look up format features. I don't think I did format features. Formats, properties. Niche penguin subscribed. For the 4th month. Oh my god. Thank you, thank you. That's very, very helpful. So helpful, especially with as terrible as I feel all the time. Ay, ay, ay. Kinda almost didn't feel like streaming today at all, to be honest. Chroma. Oh, format feature flags 2. Water. Crunchy snack. I think I've been doing okay on water. I had some chewy snacks, but not crunchy snacks. One of these days. I'm gonna have to open those up. But you can bet that once I get into the crunchy snacks, I'm really gonna get into the crunchy snacks. I don't know that I've... Yeah, I haven't really stretched at all today. Although I did get up a few times to close the door. Does that count? No. Probably does not count. Format properties. Get physical device format properties. Is there like a format properties 2 thing? I feel like if there is, I'm gonna need that one. Yeah, this one. Get physical device format properties 2. Which I did not put in my list of things here. Physical device format properties 2. Which will consist of the format properties structure. Let's see, this can be a pointer to format properties 3. Format properties 3, yeah, You don't normally run into a third one. There's so many layers. So in format features 2 is all the previous stuff, I think. See, these are bet fields. This one has like optical flow, video decode, acceleration structure, vertex buffer, fragment density map bit, fragment shading rate attachment, host image transfer, video decode output. So yeah, I need format properties 3, which comes from the format properties 2 structure. That's part of physical device properties as well. Instance. Where's the instance? It's just a way over there. So I think I want to get I want to make a thing here. It should be like get or format. Yeah, get format properties. We should take a device and maybe a VK format properties 3. And then we do v instance. Let's see, it's I thought there was like a type for the device. The physical device. Physical. Do you see the word physical in this list? Because I certainly don't. But it's definitely defined. Wait, that's not the device. This one's the device. This one's supposed to be like get. Physical device format properties 2. And then we give it do these have prefixes? I guess on the instance I gave them prefixes. So it needs to be a format properties 2 structure. And then I'm going to fill in structure type format properties 2. I have to set next, but for now we won't. Or I could, actually. We could just set this to properties out. If the structure type is not structure type format properties 3, and we'll set that to structure properties 3 because that's important. I think I'll also null out next in this case, just because I don't trust. Do not trust. So now I could be like format properties 3. For a given format. I don't know which format it is. Exactly. Structure type. The structure type should be... I guess we'll fill that in there. Sure, why not? So we're gonna do device, whatever that format was. And then the properties. All to find out that it probably has the bit, and I am maybe overcomplicating this just a little bit. I think it's buffer. Is it buffer features? I think it's buffer features. Format feature. It's called format feature too. And we want acceleration structure vertex buffer width. Go running away from you, this stupid thing. Why must indentation always be broken? Without fail. Yeah. Kind of weird if it didn't. It would definitely be kind of weird if it didn't. Let's put this down here somewhere. Up, right, this way. It's like get build memory requirements. Query acceleration structure size parameters. I don't know if I need those. Although I might. Let's see. We also need some scratch memory. Oh, scratch memory, why? So I think we can get some from here. Get the scratch size. 256 a line. That's not a reference. Make that a reference then. We will make all the things into references. So this should get some scratch memory. Memony. Yeah, okay. Now we can return scratch memory. Possibly. Possibly. Yeah. Uh-huh. Yep. Mm-hmm. Sure. Yeah. Right. Yeah. Yeah. Uh-huh. Buffer usage shader device address bit. Did we do that? I don't know if I did. This would be the acceleration buffer. And I want to find the references to it. Vertex buffer, index buffer, uniform buffer, storage buffer, transfer buffer. I don't see shader device address. So we're gonna put that on there. Otherwise bad things will probably ensue. And then we have buffer, device, address, info. Buffer, device, address, info. Comes in 3 flavors. Regular flavor, KHR, and extension. Delicious. Absolutely delicious. If buffer is non-sparse and was not created with device address capture, it must be bound completely and contiguously to a single device memory object. I think it is. I want to say it is. I kind of hope it is. Starts questioning. So we have the device address. I don't think there's any extensions for that. Wait, what? Why is my overlay being, like, stupid right now? You said that XE was subscribed at tier 3. Is that right? Hello? Notification thing? I think notification thing is broken. It can't handle a tier 3. It doesn't know what to do with this. I don't know what to do with this information either. E? E? I'm gonna drink my water. Lazy, manually resubbing. Well, you don't necessarily have to manually resub. I think. I don't know. Prime doesn't auto-renew. Twitch, please. What is this madness? Why would the Prime not auto-renew? What's the point of that? It's like they don't like Prime anymore. First they hide it, so then it's really hard to find the subscribe with Prime button. Which, by the way, you can subscribe with Prime if you have Amazon Prime, and it's basically free. But yeah, you have to like click on the subscribe button, and then there's like an option for it on the far right, I think, that's like elevate your subscription or something like that. And then you have to click on Prime specifically. It's like they hide this feature. It makes no sense. It is truly the darkest of dark patterns. And now you're telling me that it doesn't auto-renew. You have to come back to the channel every month and then click it manually. That sounds awful. Well, that just sounds ridiculous. I don't know what to think about that. I don't know. They have very many words.
If the descriptor buffer feature is enabled, an alternate way to specify descriptor sets is via buffers rather than descriptor set objects. I don't know what this feature is that I just stumbled into here. Resource descriptors. Yeah, physical storage buffer access. That is what I am reading about right now. If multiple buffer objects are bound to overlapping ranges of device memory, implementations may return address ranges which overlap. The returned address must satisfy alignment requirement. Buffer device address info. Buffer device address must be enabled. Where is this one? This is in Vulkan 1.2 features. Or physical device buffer device address features extension. I like how I'm basically just turning on all the features as I find out about them. So this one is part of physical device Vulkan 1.2 features. It's 1_2. Yeah, okay. I wonder if there's any overlap here. Dynamic rendering and the other thing.
Yeah, I guess that one's standalone. About synchronization too. Key extensions. It was on my to-do list to mess around with extensions some more. I think it was like maintenance 2 or something. Don't remember. I kind of wish it would tell me what all the extensions are. I don't see synchronization 2 in there. Depends on version 1.1. It's promoted in 1.3, so if I don't have 1.3 in the features list, then I guess 1.2 is fine. So I want this for... Oh, where was I? I don't remember where it was. Get buffer address. Buffer device address. Yeah, that one. I suppose I could make like feature masks or something. Seems a bit excessive though. To do... maybe warn about missing features and mask desired features. So yeah, I need buffer device address. This one is like used for ray tracing. I don't know if I did acceleration structure, if acceleration structure had a feature bit or not. Acceleration structure properties. That's a maybe. There's just a few of these. Yep. Right. Yeah. I should probably put all of the properties inside of a structure that I can just shove off to the side and not worry about. No time like the present. Be like, I guess I'll clean this up. And then I could replace that. I can either put it inline or make it a pointer. Opacity. Micromat. And then what is this other one that I was looking for here? Acceleration structure. Why can I not tab between these stupid things? Physical device. Acceleration structure properties. It's structure type. Physical device. Acceleration structure properties. There are no rays. There's no rays. I'm going on a journey here. More hydration. Delicious hydration. This is it. Device. Properties. Redefinition. Redefinition? Physical device properties. I guess I already have one. I'll get these damn rays eventually. And maybe I'm close. Maybe I'm not close. I don't know. This one. That one. We want acceleration structure. All the properties. Yeah. I didn't check any of these things, but they are kind of important. Like a minimum acceleration structure, scratch offset alignment. Maybe I should do something with that. Is it build structures? Yeah. It's like this scratch memory here. Instead of using 256, we can use property, acceleration structure, min acceleration structure, scratch offset alignment. Because that's not a mouthful. I can just imagine that these are like parked in static memory in the DLL. Filled in with a bunch of static values. Be like, here, you want a copy of these? Let me just mem copy these for you. Or maybe they're in some blob of data. I don't know. Maximum descriptor set update after bind acceleration structures. Wait, you can have a descriptor type of oh wait, of course you can have a descriptor type of acceleration structure. What am I thinking? So far, I have set up some of the preliminaries to be able to generate acceleration structures. And now I think I have set up, I think, all the features I need to have enabled. And I got the properties in case I need access to those. And we have a buffer area. And then I created a bunch of these. I'm going to need to like clean them up, aren't I? Yeah, we need to clean these up. So I want to do shut down. And then we'll do device. And then these will be, I think I can use reset. That should destroy them. And then in order to make this tick, I'm also going to need a command buffer. Because I really don't want to, yeah, such destruction. That will destroy all of them. I will reap the memory from the dark depths of the device. command buffers. Yes, command buffers. Where are the command buffers? Not there. Nope. Not there. I want to find references. I probably want to find references in my own program. Thank you very much. See this right here? This is not helpful. I could probably get further with a text search. Free command buffers. Transfer control. Create a command pool for transfer control. See, that's on that queue family. Which I guess is okay. So we have literally just this one and the one on the frames. Transfer control. Instead of transfer control, what if I made an entire object for all of the ray tracing stuff? I will just call it the ray tracer. Sure. Why not? And we'll take all of the acceleration structures and we'll put those in the ray tracer. It's not really the ray tracer, but it is sort of like a thing that will hopefully manage all of the things that I need to do. Let's see, it's probably going to need a reference to the device or a pointer. I guess I could use... I guess we could use a reference. Okay, and then the acceleration buffer, that's going in here. The, what's it called? I don't know what it's called. I guess I'll take some of this stuff from transfer control and we'll put that in the ray tracer. Because maybe I should have a command pool for submitting things. And a fence. I have so many fences. I have so many fences, it's not even funny. When in doubt, fences. Everywhere. Fences everywhere. We have queues. I don't know if I want to have a queue object. I could put the properties in the ray tracer, maybe. Be like, you want to do some ray tracing, then you gotta put this stuff. Yeah, but not now. So I want to create pool thing. Just stick that in a subscope here. And then we will do RT pool. I like how that's really close to the buffer here. Then we want fence. Make a bajillion fences here, of course. Make a billion fences and no semaphores. What kind of universe is this? This one is now property memory. The other way around with an extra dot. Didn't even look for errors and stuff yet. Device, property, physical device, property, memory, property, property. So yeah, when we do make device, I just feel like the physical device should be part of the constructor instead of being stuck here arbitrarily. But that is kind of how I do things sometimes. I suppose I could embed the properties in the... Like, it wouldn't be too hard to move them. No, must not fall into that temptation again. I want to get the raise. We need the raise. Depth features. The features. All of the features. There's not very much water left. I'm gonna have to get more water again, aren't I? Alright, where is free command buffers? There's RT commands. Can't believe they have still not done an abstraction for command buffers. But I have not. Initialize. Initialize. Yeah, why am I doing this? Are they abstract enough? Well, I mean... Or thin enough. Are they thin enough? I guess if you were to, like, free them and then reuse them after each each interval, then I could see like maybe I would just put them as a lightweight abstraction under like the pool, be like, this one exists. But if I start attaching other things to them, like synchronization values or something, I don't know that I would abstract the command buffers themselves, but I would attach them to a concept. Kind of like how I did buffers or something. Like it would be alongside something. But I feel like there is some level of abstraction for like a pool and allocating a pool or from a pool like here. Because I feel like I've copied this allocate thing a few times here. So we have upload, init textures. Wait, isn't there like another one? It's like allocate buffers, create a pool. So I kind of want maybe something for the pools, honestly. Something fairly kind of sort of lightweight, I think. Could help. It could help. Or it might not, I don't know. Oops. What am I looking for? Build structures? I think it's build structures. Oh, I moved build structures. This isn't part of device anymore. This is part of Raytracer. So yeah, acceleration structure is now going to need a reference to, I guess, Raytracer. Which doesn't exist. And it's back all the way up there. I guess that means I don't need device anymore. Raytracer can point at device. Except we don't have Raytracer in definition. Scope. We don't have it in scope. So this has to go elsewhere. So we can do device and then RT. Now all of my function calls have to be explicit. Because we're out of that context. Will I ever get all the way? Ever? Refactors abound. This almost makes me want to switch the thing, the properties. At least the acceleration structure functions haven't changed much. Much? Yeah, much. Success? There's never enough success. Is there? No. Commands, we'll do reset, we'll do the pool, the delicious pool. What does the 0 mean? I don't remember. Flags. Always with the flags. That's why I don't like 0. 0 is so undescriptive, and then they have like flags as none or something like that, but that doesn't exist. Wrap all the functions. I don't know if I feel like wrapping all the functions right now. That's kind of been on my maybe to-do list. But it sounds like a pain. A massive pain. Let's see, I need to also allocate begin. We need to begin. What is begin? Begin primary. We can just put this all the way up at the top. Somewhere up here, I have a bunch of static constants. Okay, so, yeah. There. that will begin the command buffer. And then somewhere down here, I'm just gonna, yeah, just take all of this. Sure. I feel like this is a thing that needs to go in some sort of abstraction. As for which one, I don't know. I think there will be a return false at the end of all this nonsense, though. Alright, so we have... I think we have the same kind of fence submit thing. I think there's like a way to make the timeout be like all the timeout. I don't know if there isn't all the timeout. I know it works for the other one. I don't know if Wait for Fences would be very happy about me doing that, though. Client can reasonably expect the delay to be on the order of seconds. I guess I could make like this some number of seconds instead of was it nanoseconds? Oh why? Why? Was this a billion nanoseconds? Yeah, that sounds about right. I think I want millisecond, maybe. Millisecond from nanosecond. That's one. So this might be 1 million. Million second, and then if we want to go up to seconds, that would be billion. Cool. So I will wait for 10 second. That should be plenty. Mm-hmm. Yeah. So now I can supposedly submit some commands. It's a very elaborate-esque function. So, which commands do I want to submit? Probably build acceleration structures, or I don't know. Get buffer device address. Maybe get buffer device address. Wait, that doesn't have to go in a command buffer. Command right acceleration structures properties. Maybe? Command right acceleration structures properties KHR. Previously built acceleration structures query. Pipeline statistics timestamp. Occlusion. Query type. Video encode. This says all kinds of things. Before copying an application must query the size. Well, I'm not planning on copying them quite yet, but I am curious how this command works. What the heck is this? Motion instance? Don't want motion instance. I suppose I could try to build the buffers, or I could get... I try getting device addresses. I still have to like fill these in with like actual data. Like some form of geometry. Device address built on device. So I need to copy those, maybe? Vertex data. So I mostly just need some vertex data. Where am I going to get vertex data from? Maybe I steal... Maybe I steal it from the... What's it called? You can probably get it from a model. That requires waiting for a model to be loaded. But is well within the realm of possibility. Or we could make something again. I don't know, I want to make something again. I just want to get my data from something that already exists. Would a simple model be an... I don't know, that's the thing. Like, I think it would be enough to test, like, the process of building one, and then, like, passing it to a shader. But why go through all the effort of building one if all it contains is, like, a triangle? Sample models. I think you're missing the point here. I have models in my software already. Like, we already load models. They're used by the standard pipeline. I don't know that I would have a whole lot of complexity behind using my own models. But the point isn't to test complexity, it's to test something. Like, put a triangle on the screen after ray tracing it. Or put a cube on the screen after ray tracing it. Like, that's the level of simplicity that I'm going for, is just put something on the screen. And I don't really feel like trying to grab more memory to put a triangle. A single lonely triangle. I mean, 3 cubes and offsets that would use... I don't know, cubes would use the AABB pipeline. Wouldn't even use triangles. I could make cubes out of triangles, but it seems like a waste. Maybe I can figure out... Maybe I could figure out how to get Eris. We could load Eris. That might work. That would be a challenge. Because I want to find the models in the model list here. Anyway, models is larger than 3. So we establish a model as being like in use. Yeah, maybe I just kind of snag this here. Mm-hmm. And this thing is the model's object. This is an index. I think this is like a model pointer. Oh, let's this predicate should probably be out here. And then I also want to check if the ray tracing has like some sort of condition on it. And like if it's not loaded, whatever loaded might mean. More hydration. I'm gonna need to get more water. I think I'm out of water again. Build structures. We'll do loaded equals true. We'll take this line. We'll put it in next to draw commands. Under this little silly thing. We don't have a frame there. But yeah, we'll do something like that. And then we'll put the model in there. Somehow. Right. I need to get more water. I will be back shortly-ish, kind of. Oops, that's not me. I want this one. Oh no, and then I want this one. This is also, I guess, the perfect time to like maybe stretch a while because I haven't done that at all this stream. Absolutely slacking. I am slacking. I have acquired hydration. Finally. Yay. Help. Uh, oh. I decided I would stick some toast or bread in the toaster to become toast. Because I figure having something to munch on would help. So I sort of have to wait for that a little bit. Well, that's going. I figured I would do some stretching. Or at least what stretching I can do. I wonder if I will ever be able to reach my toes. They're so far away. So close, yet so far. I don't know if I'm ever gonna get there. Too far. It's just too far. delicious toasty bread. What more could I ask for? Something on the delicious toasty bread. I think not. Too many function arguments to function call argument function call arguments. Oh, I'll have to fix that, I guess. Of course I'll have to fix that. That's exactly what I set out to do to begin with, was to fix this whole structure. I'm gonna fix all of it after I eat my toast. I suppose the question is, does anyone want a crunch? It's rye toast, and I stuck some butter on it. And so it's basically just toast. But it does have some flavor. So crunchy. Crunchy. I usually refrain from doing the crunchies. However, cannot resist the opportunity. I don't know why I say short break time. Just like, nope. Nope, it's never short. It's just never short. I spend like so much time just munching and crunching and what is that? Is it a device model? I think it's a device model. Yeah, it's device model. What's inside one of these? A couple of offsets. Some sort of update. Contiguous. 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 Oh no. One. 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 Whoa. 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 Miss this part right here. Very. Whoa. Whoa. Yeah. So. There should be an index relative to the buffer. Which I think is in one of these. Which has this particular structure here. So, when we're inside of the Raytracer, I think what I can do is get a certain number of indices. With the indices, I don't know how many indices. Let's see, would this be the model? I guess it'd be index count. Perhaps? So it'd be the model vertex count minus 1. And then we have the vertex size. So the stride here would be the size of the, I guess it would be device vertex models. Maybe it was vertex buffer. And then we do the vertex type. No. No. It's vertex buffer and then vertex size. Yeah, that should be the stride, I think. And then I would need to fill out all of the device indices. Yeah, device indices. Build ranges. Primitive count, primitive offset, first vertex. Transform offset. I don't remember what those were. Only that I probably have to fill them out. So, in order to make these work, I need to Probably one of these get buffer device address calls. Probably up here. See, buffer usage shader device address. Something or other. That'd be device vertex models. Buffer device. I'm gonna just borrow this. And we'll just throw that on there. Yeah, sure. Hopefully that works. And then we're going to need to get the offsets of the different aspects. So this would be like the bottom triangle something or other. Bottom triangle, it's got one element. Want the geometry. Which is triangles. And vertex data would be the device address plus the model. Let's see, I think it's vertex copy, destination offset. Then index data is device address, model, buffer, index copy, destination offset if the model is an index count. This would be for all models. And then we also need to get the acceleration structure data. For like the top level thing here. Yeah, this structure. Top level instances. Get acceleration structure device address. So that'd be device get acceleration structure device address, which I conveniently included here. Acceleration device address info. Put me on that line. Acceleration structure device address info. You gotta love these names. They come in so many flavors. Acceleration structure device address info. Don't know what goes into one of these other than like a pointer. Right where I want to go. Perfect. And that returns a device address. It must be a valid structure handle. So I'm guessing it will be the test triangle buffer. Probably. Seems like an idea. Like how I put another layer of indirection. I didn't really bother to name them very well. Server. I don't care about server. I don't know what that was about. I feel like that probably means that I've broken it, though.
Because let's face it, I probably broke it. The stretch. I thought I just did one of those. I probably have to like manually put stretch on cooldown if I actually stretch. Okay, maybe I didn't just do one of those. It's been a little bit of time. So I guess we'll do more stretching. Yeah. More stretching. Remember, very important. Stretching is important for your health. Look how healthy my eyes are from all the stretching they do. Right, yeah, I actually have to get out of my chair in order to stretch. Uh-huh, yeah, again. This time with feelings. Ow. Well, the toes. I still cannot touch them. Yeah. Yeah. Ow. Ow, 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 ow. Actually, I made a thing for this the other day. Where was it? It was this one. Yeah, copy that. Where did it go? Where did it go? It was like stretch time. Because it really is. Ow, ow. Ay, ay, ay.
it used to be so much more stretchier. A long time ago. I did something to one of my arms at one point. It just doesn't feel right anymore. I don't know if I'm getting stretchier or if I'm getting marginally more exhausted. I don't even know if some of these are proper stretches. They feel like proper stretches. You're back again. I am surviving. I am stretching. I think I'm done stretching though. Yeah, I think it's plenty of stretching. Where are we at here? Where are we? Where we at? We're back here. It's like really hot in my room. I turned one of the fans on. One of the mini fans. I have a great many fans. They constantly blow air on me. Well, not constantly. I only have like 3. 3 useful, delicious fans. E. Very E. Oh dear, very E. I feel like this should probably be... Maybe this should be a function. Buffer. Just get like a buffer device. You're like, yeah. The device is on the device, or the buffer on the device. Maybe I stick the shader device address bit on things. I don't know if there's any downsides to putting that on there other than it potentially not working. Because it might not work in all circumstances. So I think I'm gonna need some memory for probably this instance thing here. The array of instances. Yeah, that. The array of instances. So I might just have to arbitrarily acquire memory somehow. So this times, I guess it would be the span size of top level instances, maybe. Maybe. I want the M. The M is important. And then I can acquire some memory here. Maybe possibly, perhaps. I don't know how big this thing should be. I'll just use the 256 alignment that I've been using. Alright, so the instance offset here. That can go. Maybe on the Raytracer. Instance offset. Yeah, and then we'll set this one. And then that one. And then we'll acquire some memories. Some delicious memories. Get buffer address something or other. We will return scratch memory. Maybe if we do a queue submit successfully. Or maybe we can do it unsuccessfully, I don't know. So we should start the command buffer. Probably end the command buffer. We put something in the command buffer. Yeah, we'll do the whole 9 yards here. Why do they say 9 yards? What if it's 9 meters? Alright, I think I'm gonna need a copy command. Yeah, we're gonna need a copy command. It's the only way I can see this thing getting loaded into memory. So I'm gonna need the host offset. And we're gonna have to get this in host memory. Let's be like device, the buffer on the host. We'll get some of that delicious, tasty memory. And then we get the device, the host buffer, host address, the geometry instance host offset. Isn't a mouthful, is it? No, clearly not. I will do a delicious mem copy to the host pointer from the instance array thing. And we'll use the instance size. Alright, we'll do this after we've established the addresses of stuff. Because in here there is an acceleration structure reference, I think that was. And that has to be the device address of the structure that we want to cross-reference. So we copy that into like the staging buffer, and then we copy that staging buffer with a command in here. I guess it would be copy Copy buffer. So you have the command buffer, the source buffer, the destination buffer, and then the copy regions. So the source buffer is the device buffer host, and then we have the acceleration buffer. And we have the region count. There's only one copy here. Copy buffer info 2. This does not sound right. It's a buffer copy. Buffer copy. Yeah, that's real helpful. So we have the source destination size. The source is the geometry instance host offset. Destination is the geometry instance offset in the other buffer. And the size is the geometry instance size. So we'll point that there. And because copying can't just be an easy thing, I'm going to have to put one of those pipeline barriers, I think. Find one for buffer memory. RPG? RPG? I don't understand. I don't understand. I never understand. Will I ever understand? RPG, the rocket launcher. The propelled grenade, the rocket propelled grenade launcher thing. Yeah. This will be a span size. I don't remember what this required. Buffer memory barrier. Buffer memory barrier. Technically, there's only one. Technically. buffer memory barrier 2. Oh, come on, there can't be that few of these. There's one. I found one. Yay. Do I need to fill in this silly thing? Copy, transfer rights. Whatever the second stage is. The queue. Got buffer. Device. This is copy info. Copy info. Wait, if it's the destination, it would be the acceleration buffer. Device. Q0 family, I think. Yeah, we'll just do that. And then I have to figure out which bits to use. I guess it's acceleration structure build? Probably. Let's see a whole lot of other options here. And we get copy and we got build. So I'm gonna build. Acceleration structure. I think we are reading from this particular buffer here. After we do the copy transfer rights. Yeah. 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 I mean, technically I could do build one of the buffers. The triangle one. I don't know if that would be a great idea though. So let's see here. After we do all of that nonsense, I think we could do build. Maybe? I don't know if they want to build the AABB one, though. So we're just gonna take that, put it somewhere else. Try Intel Arc Accelerator. I don't know what you're talking about. But I am gonna hydrate. Because that comes up every so often. Yummy water. I'm gonna go with yummy water. The threat to AMD and NVIDIA. Well, I was kind of like talking about that yesterday. I'm like, they're a real contender for the mid-range. I would not discount them as being something like they are definitely going to be a mid-range thing. Fairly significant. Now, I would probably say that I can't really compete with any of the companies. Like, if I wanted to make a GPU, which I kind of do, it would be a hobbyist thing. Let's see. Primitive count. Where is it? I need build range info. I misspelled structure. Build range info KHR. Number of primitives for a corresponding acceleration structure geometry. Primitive count and primitive offset. If the geometry uses indices, primitive count times 3 indices are consumed from index data starting at the offset of primitive offset. What about Intel's management? I don't really know what the situation is with Intel's management. I honestly can't comment on that too much because I don't know. like they probably aren't moving as fast as I might think they are, but like then again, I would give myself pause on that dilemma because I don't know how fast they're going. Like they are kind of advancing a lot in the GPU space. The CPU space is kind of meh. So if anything, they should probably like rethink how to do stuff in the CPU division. But I don't know about some of the other divisions that Intel is managing, like the graphics card stuff from Intel seems to be going at a breakneck pace as far as I'm concerned. It seems like they're always coming out with like new drivers for the thing. Trying to get everything in the good way. Software, AI accelerators. I haven't looked into too many AI accelerators. Wouldn't it be hardware AI accelerators though? If you're doing them in hardware. Software accelerator is kind of just doesn't sound right. But when it comes to like AI acceleration, that's something else I haven't really looked into too much. Like I am kind of interested in AI acceleration. I'd love to like mess with that stuff someday. See what it's all about, but when it comes to like the really 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 big data sets, I don't know that I could comment on that too much. I just don't keep up with that stuff. If geometry does not use indices, vertices are consumed. So I would have to like divide the index count by like 3. Right. Index count divided by 3. Integer division. That's fantastic. And then primitive offset. Bytes into memory where the primitive data is defined. Let's do vertex. Is it vertex or is it? The index of the first vertex. So I guess it would be destination offset. Or no, because it's the offset in bytes into the memory where the primitive is defined, and the primitive is defined using a device address. So that would just be 0. And then we have the first vertex. And then the transform offset. Offset in bytes into the memory where a transform matrix is defined. Count and offset are interpreted differently. It uses indices. Indices are consumed from index data starting at offset, primitive offset. First vertex is added to the index values before fetching vertices. If it does not use, then these are consumed from vertex data starting an offset of primitive offset plus vertex stride times first vertex. Transform data is not null. A single structure is consumed from transform data at an offset. Okay. So most of these are 0 except for the primitive count. So what does this get? Where do I put this again? Build structures. Build range infos. Such a weird name. It has to be geometry count. Structures. So if I only have a single structure, then there should only be like one cluster of primitives in the structure, I guess. Also, I need to fill in the acceleration structures themselves. Yeah, the pointers for those. That's the vertex stride, that's the index data. Not the infos. I think it's 0, and then we want, let's see, the source structure is going to be top level. Destination, that one's also going to be top level. I think 1 is test. triangle? Sure. Then double check all this. This bucket is not Discord. That's not surprising. My Discord channel is it's very quiet. Let's see, we have the copy here. Now we want the acceleration structure build thing to go here, I guess. Will it though? Will it though? It was another one of those little fun facts. The Discord link is unlimited time to live, but a limited number of uses, so that I don't accidentally get like flooded. So after so many people join, I have to create links again. Highly exclusive of me. Highly very exclusive of me, isn't it? Mm-hmm. So after we do this Q submit here, and we build this supposed command structure, time to live. It's how long a link lasts. It's how long anything lasts. Packets, links, an insect in a video game before its brains are blown out. People, maybe. We don't know the time to live for people, though. It's very indeterminate. I don't want that there. I want that on structure. Let's see if I can start cooking this thing. I mean, do we have the model? Yeah. We got vertices, we have indices, we have some copy offsets. Get a bunch of addresses for here. Why did I do that? I don't think it's supposed to do that. Where did it go? Where did it go? You know, this would probably be a span, so I don't mess it up. When you finally launch your VTuber, do the big rebranding. You're gonna be unstoppable, are you? With 1P. Unstoppable. Absolutely. I'm kinda stoppable though. Let's see, I want to do... What do we want to do here? I want to do current info. Maybe a span in the info structure. The current info sizes, or... Let's make a span. No, I need a span. Ahead of time. Or I could make this an index. I think a span would be better. Don't know. I could just make it a pointer. Like build sizes 0. So evil using pointers. I'm using pointer arithmetic. Evil. Pure evil. Alright, well, the current info. Geometry count top level. Oh, we need that too. We need the geometry count. Dark stack. Dark stack. Welcome to the world of aperture science. No, wait, that's not right. I think I want geometry counts to be an array of pointers. Maybe I should use an index. We want top level. Bottom level triangle. Bottom level, the other thing. We got 32 pointer array? Or is it a pointer array? Wait, these are all arrays already. They're already arrays. That's not where the space goes. foiled again. Current info index, we're just gonna increment that. This doesn't need to exist. I don't think. Let me just say the current info index here, and then this one is going to be the geometry count at the current info index. You're here to lurk. I am fine with lurkers. We got lots of those. Enjoy your stay. So, yeah, back to this. We will get rid of all of these. Finally delete those. Yes, And then I don't feel like doing query pools to make properties to copy things. That sounds like a bad time. So now that I've completely renamed all of that stuff, we're going to run again and see what horrors await me. Where is it? It is build sizes. Yeah, we should be able to fill in, I think, the first two of these. Well, that one has a lot of stuff inside of it. And then we do a bunch of make unique commands. Create acceleration structure. I gotta see how this turns out. I guess it's successful. Very uneventful. Let me put this one at a different offset. More success. Great success so far. That's an offset. More success. We acquire some memory. Not very much memory. I wasn't expecting gobs of memory or anything. Let's see, scratch memory. Minimum acceleration structure scratch offset alignment something or other. So that's all fine and good. Device address. And then we get the triangle structure. And I guess I can just add these. It'll be fine, right? Right? Surely. Hopefully. Maybe. Then we get the acceleration structure address, which is that number. Fill in some objects here. Hope this mem copy doesn't kill me. Allocate command buffer. Begin command buffer. Let me copy some memories. Hopefully. Build acceleration structures has thrown an access violation. It just couldn't have gone according to plan. Wait, why is the range... Oh, that one is empty. I forgot the other one. I forgot there's two of them. Yeah, for build ranges. This one's for the triangles. And then this one... We need like another... We need another one of these. Just like build ranges, instance. How'd this work for instances? Build range info. If it is instances, primitive count is the number of acceleration structures. Primitive count acceleration structure instance. Or acceleration structure geometry instances data are consumed from here. The address of an array of host or device addresses. The address of an array the address of an array. Address of array. Or the address of an array of... The address of an array of addresses. Or an address of an array. I just couldn't make this easy now, could it? Yeah, I didn't do that one. Did not do that one. This has to be the address of an array. Of acceleration structure instance. Okay, wait, didn't I do this? I think I did this. Yeah, I think I made it into an array, and I might be just a little paranoid. Maybe just a little bit paranoid. Do I want the instance? This address has to point at whatever the offset is. So I need the buffer address of the what's it called? Oh, the what's it called? I need the acceleration buffer address. So I can offset that one. Because, yeah. So we're going to put another one of these. This time I want the buffer for the accelerations, structures and stuff, because that's where I squirreled this thing away. And then we want to access the geometry at the top level. Item 0, I think it is. Geometry. It's not going to autocomplete. Is that even the right one? I don't even think that's the right one. Yeah, it's geometry top. But there is only one of them, so... we don't do that one. We want to go into the geometry. We're doing instances, data, device address. It's going to be the device address plus the offset of the instance class data thing, whatever that's called. A blog or GitHub. No, I don't actually put any of the Vulkan stuff kind of anywhere. This has probably been the first major project that I've worked on that includes Vulkan, other than like one that I did a long time ago. And never published this project yet. And I'm not very good at the whole blogging thing. Yeah, I don't know what to do with that kind of thing. Info dump my random thoughts. I don't know if that would end up going too well. Sorry to disappoint, maybe? But that's kind of how I am. I'm very half-baked. Never thought people would be interested in what I do. Because it's been like, I don't know, years. Years? Lots and lots of years. And I haven't exactly gleaned a whole lot of attention. Till somewhat recently. I guess that last stint where I did like operating system development on stream for a few months, that kind of had some attention. We go again. Here we go again. Here we have 2 of these. Our build info. 552. 552, that doesn't seem right. I think I copy pasted that the wrong way. There's just one of these. There's one instance. One 552. Whatever the info structures are, which I assume are filled out correctly. Oh, it's top level. This one should be a bottom level. Scratch data. Oh, I didn't fill in the scratch data. Well, I guess I'm glad I checked that. Yeah. Check all the things. Wait, if I have to... Wait, where is the scratch data? Scratch offset, scratch buffer size. Yeah, we're gonna take this. And we're not gonna do the maximum. We are going to do a sum. So I'm gonna add these. And then it would be the build sizes. I don't really want to type that over and over. Build sizes. Current info index. Make that shorter. And I'm going to assume that the sizes returned are going to be aligned. Now, I don't like making assumptions, but in this case, I'll make an exception. And then after we do that, anyways, I think we will set the current info. We'll do scratch data, device address, and then we will put the current build scratch size in there. Maybe before we update that. Because then I can come in down here with the buffer address and the offset that I supposedly acquired. The scratch offset? Yeah, that thing. And then we can do scratch data, device address, and then we can add the scratch offsets and the device address of the current acceleration buffer. Which maybe I could put in a separate variable so that they're a little bit more less obvious. Then I'm recycling variables. which would be the device accelerator buffer. Excel buffer device address. Yeah, okay, that's a juicy name. Oh yes, imagine if I were good at doing things. Marketing myself or talking about what I do. Could you imagine the number of people who wouldn't occur to me? I don't even know what I'm saying anymore. Time to crash this thing again. I love how it just spews out command gibberish. Format supports acceleration. Yay. That's what I want to hear. Okay, so these have offsets. The infill structures have, I'm assuming, valid scratch data addresses. That one ends in 7-8 something. That one's F8 something. We have the structures. We have the geometries. Of which there is only one of each kind. It is triangles. There's no transform data. There's some vertex data. There's vertex stride. There's vertex format. This one has instances. It's not an array of pointers. We have an address. It looks fine. It failed. Validation, please. This is what I get for not logging the validation layer stuff. Then I have to run it from here. Wait for it to crash. Gotta wait for it to crash. We gotta go down to the bottom of this function here. Process terminated. Oh, there's lots of messages here. That's not good. The acceleration structure feature was not enabled. Why? I thought I did this. Oh my god. Buffer was created with all these bits, but it must have been created with acceleration structure storage. Oh my god, there's so many things that I have overlooked. Apparently. I don't mind if I just take that word there. Yep, uh-huh. And then we're gonna find the acceleration structure. I think we create that over here. As well as add that bit, because it wants that bit apparently. Acceleration structure features. KHR. It should be acceleration structure. Acceleration structure. What else? Feature must be enabled. We need the bit. We need the feature. We need the bit. Validation error. Acceleration structures geometry. Build acceleration structures geometry 0. Geometries. Instances data has no buffer, which was created with the acceleration structure build input read only bit. The buffers from which the buffer device addresses for all things must be queried must have been created with the buffer usage. More buffer usage stuff. Okay, buffer usage, acceleration structure, build input read only. Bit, KHR. Okay. What's this one? Command buffer type is info type 1 is bottom level, but acceleration structure was created with acceleration structure top level. Need to be false. And validation, wonderful. Infills 1, geometry 0. Geometry triangles vertex data has no buffer created with acceleration structure build input read only. I guess I need to add that to the device buffer as well. The one that I stored the models in. Yeah, this device buffer. Info geometry. No buffer created with read only. Alright, so if I do all those, will you work better? Nope, validation still kinda. It still throws. That's not supposed to happen. Did I do the feature? I don't know if I did the feature. Bind buffer memory. Buffer was created with buffer usage shader device address bit. The memory must have been allocated with allocate device address bit. High number of fences. Memory allocate device address bit. Really? Well, that's a bit of a new one. Was it device allocate? Index. Is it really just an index? Why is it called allocate transfer? Let's just allocate. Or allocate info. Alright, so there's an amount and then there's an index. But apparently there's an allocate device address bit somewhere. I don't know if that's in here or where, so we're gonna have to consult the specification again. Find memory allocate. Memory allocate flags. Memory allocate flags info. So we have to put one of these. Unfold functions. So you can like see it instead of jumping to a definition. I don't exactly know about that. I mean, there's sort of like this references thing. And that sort of lets me like peek at code. But that's not the same thing. I know what you're talking about, but like I don't know of myself. A voice filter? No, I just have a very good quality microphone. And that's just how my voice sounds. I never thought it was smooth though. I always think my voice is raspy and kinda meh. Maybe I need to drink more water. It's like nobody knows. Nobody knows what my crazy voice sounds like. To me, it doesn't sound that great. But that is just me. I am very picky about things. Alright, so device memory here. Yeah. Apparently I have to put a memory allocate flags info structure into the memory allocate info. The avatar is just Meisaka. The fox flavored Meisaka. Which is me. 'Tis my representation. Yeah. Structure type. Memory allocate flags info. Provided by 1.1. So I should be good. Right. Alright, and then we have the memory allocate flags here. And I want device address. What's it called? Device address bit. A bit of a delay there, but truth. And then there's like the mask of devices, which I don't need because the one bit that I would need is not there in the thing. And then if we do okay, that is way off. Kind of sort of off, but I think we could put maybe I can stick some kind of flag on the end of this. The accent. The accent is one all my own. Although if it makes any difference, I'm from like the northern Midwest sort of area. Kind of. But I've also spent way too much time on the internet, so I don't know where I glean my accents from. Device allocates. We want to allocate from something. What is the something? I'm gonna give this variable a default. It's like use device address. And we're gonna make that false. And we'll just put that on the end of the function here. Excess elements and scalar initializer. Wait, what? It's not a scalar. Don't be like this. And then allocate info. Next is going to equal flags if we set the... I don't know what that error message means. You're not helping me out here. I think I got the wrong structure. Memory allocate flags info. So then when we do device local memory, we can put true here. And that should just do the thing. Maybe, hopefully, perhaps. Will it blend? I mean validate. No. That'd be too easy. vertex attributes, ageable memory, memory priorities, all the fences. I need to probably cut back on the number of fences I use. But now we have process terminated. Why is process being terminated? What are we doing here? One of these things is being accessed the wrong way. And I don't know what it is. This is build range infos. I didn't really look that up too much. This is command build acceleration structure decay structures plural structures plural. There's no ordering or synchronization implied between any of the individual builds. The application cannot build a top-level structure in the same call as a bottom-level structure. Great. Scratch data buffer must be synchronized with structure build. Access type of structure read and structure write. Accesses to each acceleration structure must be synchronized with structure build and structure read bit or structure write bit as appropriate. Each range infos is a pointer to an array of geometry count structures I'm in the wrong window. I think the geometry count was just like 1 for both of these. Yeah. Each entry specifying the geometry count.
the geometry count or the primitive count? It's so confusing. Very, very confusion. The best kind of fusion is confusion. Not exactly sure what else there is here. Have gotta be missing something. What am I missing? It's something super, super obvious, isn't it? Maybe. Maybe. Hmm. Oh, what do we do with this? Acceleration structure. Structure reference. I mean, I suppose I could like step into the thing here. I don't really want to step into the validation layer for acceleration structures. That sounds kind of not quite right. Although having them separate from one another, I think that's probably mandatory. Well, what do I synchronize on, though? Would it be a buffer dependency, a memory dependency, something else entirely? Dependency info. Flags must be 0. Of course they must be.
Okay, what about the next thing? Is there a next thing for this? Wait, that's in dependency info, isn't it? Must be null. Yeah, so that's not gonna help me. Accesses to acceleration structures must be synchronized with acceleration structure build. I don't know if there's any buffers actually. Are there? I don't know. Accesses to other input buffers must be synchronized with build and shader read. I don't think it's synchronization related. But it could be. Because I'm trying to make 2 of these, and that's a trouble. So I'm gonna have to like split this into top level info and like bottom level info. Stick some kind of synchronization in between them. Get the build ranges. This one has to be, or should, that one's gonna be the bottom one. This one's gonna be the top level one. Because I just love coming up with ridiculous names for all the things. And then we have the info. The infos. Just too many foes. Infos will be an array of probably spam. Oh my god. Am I being requested away? I am in fact being requested away. Very much so. This thing is not very happy. I don't know. I will have to finish this some other time, I think. So I must be away. I must run away. And we will end right about here. Because it's been long enough. And by the time I get back, it's going to be time to end anyway. So... yeah, I will see you all again. Maybe. Next time. Bye-bye for now. Farewell. Yes. I will be back again tomorrow. Probably tomorrow. Probably tomorrow. Yeah, sounds good to me. Farewell. The ferrets. Maybe if I make it really quick. I guess we could. Why not? Bonus raid. Raid the ferrets before I disappear. Okay, now I can disappear. Bye bye for reals this time.